Hi folks, Mr. Teslonian back here again. We're taking you through step by step on how to build your own Wimshurst electrostatic generator. And today what I want to show you is how to build a very large one. This is an 18-inch in diameter circle right here that you see. I had the local glass shop take a piece of plexiglass I bought from the local hardware store and turn it into a nice circle here. And I've got 3 of these made just in case I damage one. I'd suggest doing the same thing if you're going to make this. Plexiglass can be a little finicky when you drill holes or cut or do anything to it. So I have 3 or 4 made just in case. And a couple of things you see here, we have a wooden dowel drive rod that we're going to use. That's an insulator material, so this will be the upper drive rod probably for the discs to spin on. You also see 2 brass rods here. These are actually going to be our combs that are going to pick up the electrons off the disc, the smaller brass rod that you see here. And this one here is going to be our discharge rod. We're actually going to have our little brass balls on the top of this as our discharge rods. And I have another aluminum rod here just in case I think that aluminum might work better for my combs. We're going to test it out and see how it does. Over here what I have are the brass balls that are going to go on top of those little brass doweling rods. They are threaded at the end, so we're going to have to solder these together onto the end of the rods. We have 2 large ones here for our discharge rod. And we have 2 small ones here that we're going to place over the ends of the combs. So there you go. And you can get these at any local hardware store. Just search around. My hands are dirty because they're covered in epoxy from gluing one of these discs together and putting the laminates on it. Another couple things that you see here that we have are a couple slip collars with Allen wrench heads to lock them onto the drive shafts. That'll help hold our pulleys and all the stuff to it and keep them in place to make sure our bearings spin right. And you're going to need a couple different sizes depending on what drive shaft diameters that you choose. And once again, we just have a larger one here for the larger drive rod that's going to be down in the lower pulley drive wheels, these ones here. So then we have 2 different kinds of plastic smaller pulley wheels. This is one that I have here that I picked out of that dishwasher we turned into the gasifier. It had a bunch of these little roller wheels in it, and they're plastic, so I think this is probably the wheel we're going to actually mount directly to the center of this plastic disc here, and this will be our disc drive gear, which is perfect because it's a nice small pulley, really small, so it'll give us a high RPM. The second set of pulleys that we have here are bearinged wheels. Another synthetic bearing wheel here. It's actually got a bearing in the center of it, as you can tell. Is actually from sliding glass doors. You can get this also at the hardware store. This here we're going to use, if this doesn't work for the center, we're going to try that out on one. We'll probably end up using this. So that might end up being our center bearing drive shaft. And I'll show you that as I kind of get going on the project. A couple of the other things that we have here. If I remove all these drive rods, and a couple, you can see here, I've pulled the metal frame off of this lower drive pulley. We're going to need 2 of those. And they'll actually be hooked together like this to give us 2 drive pulleys down at the bottom. Let me go ahead and remove those from the table. And some of these things. Alright, so real quick what we're going to do here is show you just how to put this all together in a manner that's going to allow you a perfect circle. So let me set this piece of plexiglass here in the center and kind of take you through how you're going to mark this out and put all your little discs on here, how to get a perfect center on it. What I've done is I've taken the piece of cardboard that came with the plexiglass. You can see a bunch of lines here, and I've got a shadow from the camera obviously right on the shot here. Just the way the wind's blowing today, it's the only way I can do this. And what I started out with, if I take this out from underneath there, is I actually set this piece of plexiglass down on the cardboard so that 2 of the edges were dead level with the outside 2 edges of the cardboard box. And then you can see a straight line drawn all the way across here and another one all the way across there where the actual plexiglass didn't meet the edge of the box, creating a perfect square. Instead of having a circle. Then I marked around the piece of plexiglass with my pen, giving my circle onto the plexiglass or onto the cardboard itself. Now if I remove that, here's how it works. You'll start out with your square, measure with your ruler all the way across right there. I had one sitting here to show you. Anyway, so you're going to measure from this point here on your box to that point there on the square that you drew on the box. Find a halfway point with your ruler and mark it. And do the same to all 4 sides at first. Start out with your 4 east-west positions, north, south, east, west. And then once you've got those, you're going to take your ruler, and maybe you can see this here in the shot. There's a line going from this tip here all the way to that tip there. And it makes another box. You can actually see another square drawn inside of the system. That's your first line. Now once you've measured from these 2 points, let's go over here. Once you've measured from these 2 points, drawn a line, find exact center on that. Don't go to exact center on the outside square for your next lines. You only do that for your first 4. So you're going to find your center, and that's right here. Once again, you're going to go all the way around and do that to every spot 4 times. And then you're going to draw your lines across those. Now your second set of lines here, if you can see from my 2 finger points, you draw a line from that same position here now to the new line you've just drawn. This is a little hard to see since I've already got it all drawn up. So you draw from here to here, you find your center once again, and you'd go around and do that. You can see the line here, center, line here, center, and so on all the way through the system here. And then you'd find your centers, draw your lines, and once again, you're going to come back up, and now this will be a little harder to see. There's actually a little line going straight across from here to here. And that's actually from our center marks now. It'll give us a dead center once again if we measure that, and we'll mark our lines. So there we go. That's how I got a perfect circle. And if you notice, all the lines crossed almost perfectly right here in the center, giving me a precision point to drill at. Also giving me 32 individual lines that I can put my laminates on, my aluminum plates, my induction plates across this. So now what I've done here, once you get this all drawn out, make sure your lines come out just a little bit further so you can see them past the edge of the plexiglass. This plexiglass is clear, so it comes up really nice. And if I set that back on top of there, I can just set down my ruler across these lines and draw on the plexiglass all the lines I need. Or I can just set it on there and start gluing my pieces directly into place and leaving that there until I've gotten all my laminates into place. And now you've got it into position. So here's what it looks like on the next step. Once you've done all that and you've drawn it out, this is your next piece of plexiglass. It looks a lot like that. You've got 32 lines all the way around. You want an even number of plates on one of these. You don't want an odd number. So we've got that all the way around. And the next step is to do this. Now, I've got some dirt that's gotten on this. I dropped it a couple times in the wind here. But these are actually the aluminum pieces that I've cut out from an aluminum no trespassing sign. Now, one of the issues with those signs is they have a light coating on the shiny back side of the sign. The actual painted sides underneath where the glue is. You have to kind of sand these, a little bit of sandpaper. You want to use like 150 grit, 120 grit sandpaper. Something with a finer grit to take off that really light coating. The brushes will do it over time, but just to kind of speed up the process, use some sandpaper on those. And I've taken some clear epoxy here, and I've epoxied each one of these plates initially on there to get them into place. And you can see that's a nice 32 laminate design right there. It's an 18-inch disc, and it's ready to go now to drill our center hole, put our bearing or our drive pulley on there, and we're going to start working on the frame to put this all together. Until next time, I hope you enjoyed. This is Mr. Thessalonian in the Thessalonian Man Show. Hi folks, okay, what I want to take you through real quick here is how to build the little electrostatic striker plates that are the induction plates that you're going to put on your Wimshurst. What I have here is the aluminum no trespassing sign right here. You can see this is what we're actually going to make these striker plates out of. I've taken a piece of craft paper and marked out a template out of it, something that I can use over and over again. And you can see here I've already got 4 of them drawn on this thing, so I start at one edge and just start drawing them with their lines actually directly connecting to each other. That way I only have to make one cut down this line to make the cut for both pieces. And you'd set this on there just like this. Once again, line up the bottom edge here right to the aluminum, nice and square. And there you go. Hold that down and just draw a line around it. And there you go. And that's all you're going to do to make your little induction plates out of the aluminum or copper or whatever you've got. for this Wimshurst generator. Something really simple, and just take your tin snips or whatever you have here and just cut those out real easily. You don't want to bend them up too much, crinkle the edges, so you want to be real careful when you cut these out. You don't want them folded, and if you do get a bunch of bent ones, what I've done to straighten them out is sandwiched all the 32 of them for one disc all together. Make sure all the edges are directly meeting to each other and even all the way across, and I've set that between two boards in a vise and just cranked that vise down really hard. I added a little bit of heat underneath there with the torch and then cranked it down again and let it sit overnight, and when I opened it back up the next morning, all the plates are nice and straightened out. So if you have any bends in them, that's a way to kind of straighten out your plates. Let me go ahead and move on to the next step. Alright folks, we've got both of our discs now all completed. We've got all of our little laminates all glued on there and ready to go. You can see it spins pretty well on the wooden dowel I have in there right now. We don't have any of the center pulleys glued on them yet. I just wanted to see how well this turned out, making sure that it's nice and level inside of there. It looks good, and one way you can level these out, let me go over to the other side here and show you, is that I draw a line. As you can see right here, I draw a line all the way down the entire piece of wood down to the bottom, and then I'll actually measure in from the sides, make sure that I've got my depth from the bottom to where my holes are going to be on both sides of this wood. You'll notice there's also a line over here. That allows me, and I never drill all the way through. I drill about halfway through on this side, and because I've got an exact mark over on this side, I start over there and I drill from there through the rest of the other half. And that's just in case I have a little pitch to my drill. While I'm doing this, my rod ends up as straight as possible. At least the input and the output holes are the same. You might get a little distortion in the very center of the wood, which is not as crucial. And you can see we have these two plastic pulleys already sitting there ready to go to make sure the distance was going to be correct. I've got one of the brass rods going all the way through the two pieces of wood here. We've just got a simple frame built for now. We're going to add on to this frame as it gets going to make sure that it's going to work a lot better. So one of the things here that you can see is if I spin those discs by each other, just one of them, you'll be able to see the other side there, and the paint's still on it from the no trespassing sign. So there we go. They seem to spin pretty well. I'm going to go ahead now that we've got it kind of rough set, I'm going to start gluing and attaching our pulleys here to the center of this. This should be able to turn here in just a moment once I get the lower and the upper done. Then we got to go to work on the brushes and the pickups and all the rest of the combs, and I'll show you that once we get to it. Alright folks, so here's what we've done now. I've put a little lock on the drive rod here. You can see a little lock nut put on there, bushing, and I've glued on our pulley wheels now to both, and I've sanded with some sandpaper the plexiglass and the other face of this pulley wheel before putting the glue on there to make sure there was a nice bond. That's why you see it kind of milky colored right there. That's the sanding. You'll see here if I go over the top, you'll see the other pulley wheels back there and glued to the first disc. And I actually have the drive rod right now with the little bushing on there. It's actually being used as a clamp, keeping pressure between them while the glue dries and sets. Next step here, what we're going to start working on are our brushes. This will be made out of two stainless steel rods, which you see right here. I took that from, as you can see, this is a barbecue grill, stainless steel barbecue grill or oven grill or something like that. That's all you're going to need. Any steel will work. You get that out of the way here. What we're going to do is we're going to use these rods right across the center here, and maybe you can see just how far we got some shadowing here. How far those are going to stretch all the way across. So there you go. Those are actually going to put our brushes right, let's see, about right there. And then we're also going to have our pickups right here on the sides. And so our combs will actually sit right there, and I'll start working on those in a moment and show them to you. Alright folks, we're working on the lower drive pulleys now. And as you can tell, I've got this ready to rock and roll. Just turn the outside and it rotates on the inside. And all I've done is drilled an 8/32 hole and put an 8/32 screw inside of that hole as a set screw against the brass drive rod. And I've done the same to the other side, as you can tell right there. So we've got both of our set screws ready to go. It's actually linked to the brass rod. I've set the brass rod in a vise and basically gave myself a Z design here. That gives you a nice easy handle. I can actually put a little outer plastic case writing on this or a metal case so it actually spins a little freer in your hand. with some little grommets here on the ends. We can actually stop this from riding anywhere. We'll throw another one over here just right off the end of that. And this will give us a nice centering capability. We can adjust the pulleys anywhere we want them in between that. I won't put that on until after I've gotten the belt completed, and I'll show you that next. Alright folks, we're working on our discharge rod, and you can see I've got one completed right here. And all this is a brass rod. I can show you here. It's a brass rod. I folded over the end around a bolt, the right size bolt that I was going to use to actually mount this off the capacitor. And this is just a brass ball at the end that I've soldered into place. And I just flipped it upside down, stuck it in the vise so that way the solder ran down inside the threads of the ball. Put the rod in there, heated it up with a torch. You can see the solder here, and I've got the torch there. I'm going to go ahead and put together the second one. I just wanted to show you that. That's all it is, really simple. This one here is just the main rod, the long extended piece of brass rod, and I quickly just set that ball on the end of it. It's got a threaded hole. And so you just drop that right down on the end of your rod. It's really easy, and then throw some solder inside of there and bend them to the length you're going to want. So you're going to actually, when you build your capacitors, and the distance of this whole system is going to depend on how long you're going to want your rod. But you got to make sure you got a nice dome surface. If you see any unevenness up here, a little tip right at the top or something, you're going to want to sand that down and make sure it's nice and even. Any of the bumps at the back side when you're done soldering it here at the tip of my finger, you're going to want to go ahead and sand those down also. Make sure it's nice and smooth everywhere on your discharge rod tips. So let me go ahead and start making our combs, and I'll show you that. Alright folks, we're working on our brushes now and how to hold the brushes onto our main drive shaft. And this is what I've come up with. It's just basically a little chunk of 2x2 that I've cut off and drilled a centered hole right through it here. This will actually go right over the drive shaft. And let me show you where this will actually go here. And it'll go right here behind and sitting just like that. And each one of these brush blocks, one on the other side and one on this side. And I'm going to show you real quickly here how this is going to work. So we're going to take one of these stainless steel rods, and if I can find where the holes are, you'll see I've got one hole. If I line it up, you can see all the way through. One small hole drilled all the way through the block, through the length of it here. And I've got one 8/32 hole for an 8/32 screw drilled into the top. And this is our lock screw for our actual brush rod. So when we put the brush rod through, we can actually lock it down right into position and adjust it back and forth as we need to. The bottom screw, once again, is an 8/32 screw, and that goes all the way up to our main drive pin here. And that'll actually lock this at any angle we need to adjust it on the main drive pin that we're using for the larger discs. And let me just set that through there real quick if I can. Give me a second to line that up. Alright, I'm doing this one-handed here. So there we go. That'll actually go all the way through there, just like that. And so that way, once we got that over the main drive pin here, we can set the screw in. It'll hold the brush rod into place. And we can set the lower screw, and that'll actually hold our angle so that we can get our arc on the angle right on either side. So the next step of this now is going to go ahead, and I'm going to strip out some small copper wire, and I'm going to show you that here in a minute. And I'm going to solder that wire onto the end of the stainless steel rod on either side here. And this will, once into place, you won't be able to pull that back out of there until you've actually sanded off the solder and pulled the wires off of one side of here. Once it's in there, it's locked into place, other than the adjustment back and forth by the center screw just to adjust it on the striker plates. So let me go ahead now and get the brushes soldered on, and I'll show you it from there. Alright folks, we're building our brushes now. And I want to show you just what I've done to get the wire I needed. This is a piece of an extension cord wire. You could actually use a thinner gauge wire than this, might be a little too thick. But I've got pretty thick strikers compared to aluminum foil. So this should work pretty well. And all I've done is pulled the coating off the wire. So you get a bunch of little fanned out bristles like this. And you just twist it. One here, you can see where I've twisted it up. I give it a twist to kind of bind them together at one side. And I'll cut that off right here. So you just cut those off, and that'll give you your fan or your brushes for the end of your connector rods here. And I can show you what I've done is just solder those brushes. I wrapped it around the bar a few times and soldered them on, and that gives me a nice brush, and we'll shape that just a little bit against the wheels once we get it on there. Let me go ahead and show you what it looks like when you get both of them done. And right now I just got the two brushes here completed, and you can see what we're going to do now is go ahead and rotate them up into place. If I can get far enough back, you can see the other one. So there we go. We're going to rotate those into place, and those will actually be our brushes. Right now that's on our center block and ready to go. I just got to lock that into place once I get the other one done. You've got to put the rod through the block. Do one side, put the rod through the block, and then actually go through and solder the other one. Otherwise, you'll never get it off back on there. So there's our brushes being built right now. Something simple to do. You can just solder them on, and we'll lock that into place with our set screw there in the center. And our brushes are done. And I'm going to start working on our combs after finishing this last brush. And those will be out of brass or aluminum. I'm going to kind of check it out and see which one I like more. It'll just kind of be a horseshoe piece that sits over like this. So let me get that done, and I'll show you that when we get there. Alright folks, we're working on our combs now, or our pickups, to grab the electrostatic charge being generated on our aluminum plates on our rotating discs. What I have are two small pieces of brass. I've pre-measured these. It's brass rod, and I have two little brass spheres here. And they've got the place where the threaded screw hole is. I'm going to take these two little brass rods, and I've marked my center on them. Probably a little difficult to see there, but you can actually see a little mark. I'm going to use this 2x4. I'm going to put the center mark right in the direct center of the 2x4, and I'm going to fold these down around the 2x4 to create kind of a horseshoe effect out of it. And then I'm going to solder the two balls on, and then we're also going to solder a second rod against that. So let me go ahead and fold one of those, and I'll show you what it looks like. Alright, I've bent that piece of brass rod now over the 2x4, and really quickly I just set those two brass spheres on the ends of them. And this is what the pickup's going to look like. This will be our comb rod actually sticking, let me show you here, over the sides just like that. We're going to build some Leyden jars for this, some large capacitors, and this will actually go directly into the capacitors. We still have to put some brushes off of this, which will be little wires aiming inwards, or combs. They're little points aiming inwards towards those aluminum plates. That one just came off. But those little brush pieces will be just little fingers, little single pieces of wire actually attached up and down this whole thing. And I'm going to wrap a pile of stranded wire around and pull one strand out every now and then out of the wrap to create these little points all the way down, then solder the main wrap right onto the rod. And I'll show you that here in a minute. Alright folks, we've got our two brass combs basically put together. I still got to put the little wire teeth off of this thing, but I've got the rod ready. It's all soldered together. I've got a little cleanup on the solder drips there. Other than that, it's pretty strong, and that should give us, if I go up here and show you, that should give us a pretty nice comb setup to go across on either side of those plates. And with the teeth coming off of that, that should work really nice. And it should look pretty nice when it's all cleaned up. Get the flux off of the brass and clean that with some sandpaper. This will look like a nice professional model. Instead of building it out of junk this time, I thought I'd just take you through how to build a really nice one. It's one of those things I've wanted, and I've got a 4-foot in diameter. One of these being built right now actually at the glass shop. Taking 1/2-inch plexiglass and cutting me a 4-foot, two of them, 4-foot in diameter circles, which I'll actually router in the positions here for the aluminum strikers. They'll actually be 1/2-inch aluminum strikers that I'm going to put into that 1/2-inch piece of plexiglass all the way through. So you'll actually router in all the way through the 1/2-inch piece, the same shape as these paddles here, or at least bigger than these for the 4-footer. And then I'll actually expose the back side of the aluminum out the other side, and then I'll just take a thin piece of 1/8-inch plexiglass and laminate that over the 1/2-inch piece over the back. So really in the end we'll just have two 1/8-inch pieces as our dielectric between the two striker plates on either side. And I'll show you that once I get that piece and start putting that into production here. And we're going to actually hook that large 4-footer up to a giant windmill, and we're going to have nice cascading sparks, electrostatic sparks coming off of our 4-foot Wimshurst electrostatic generator powered by wind. And I'll show you how to use that for some really neat science experiments. Alright folks, we're working on our brushes now for our Wimshurst electrostatic generator. As you can tell here, I've got most of the little wires crossed across this, and I want to show you what I did to do that. Is I just have a single strand of this nice thin copper wire here, and I've just wrapped that strand around each spot here 3 times and then circle it around, tied it off on either one. So each one of these singular lines is actually 3 of those little strands going across. What I'm going to do now is take the solder and go ahead and solder each one of these little points on both sides onto the copper rod so they don't slide at all. I'm going to make an initial cut down the center of all those wires, and then I'm going to put it over the discs and actually give myself a little bit of a measurement exactly where I'm going to want to cut them back to give ourselves maybe 1/8 of an inch or so of distance between the end of these little wire tips and our actual aluminum disc face. That'll allow the plasma to transfer, to build up, and then it'll transfer and arc the electricity from there over to our brushes. And this will actually grab what we're looking for and put it into our Leyden jars, which I'm going to start working on after I finish the 2 of these. Let me go ahead and solder this together. I'm going to make the cuttings down the center of it, and I'll show you it from there. Alright folks, we've completed our pickup brushes. You can tell we've got all the wires now all soldered on both of them. We've got our ends capped with a nice little brass sphere on there. And I've drilled through at an angle on a large size washer here. And just put that into that brass rod through that at an angle so that when that washer sits flat, so will the pickups. They'll sit at a horizontal against our discs there. And that will allow me now to attach the top of this washer to the top of our homemade capacitors, or Leyden jars, which we're going to start working on now. That's our next step. Now that we've got all our brushes, we've got our combs complete, we've got our double spinning disc complete, our drive system, we just need a couple capacitors now. We've already got our discharge rods ready to go to attach to the top of those capacitors into the top of these also. Let me go ahead and start building those, and I'll show you what we're going to use. Hi folks, Mr. Thessalonian back here again. This is a word of safety before I get started here on this video. I want to tell you that these are no joke. These capacitors at this size will absolutely lay you out if not kill you. So do not attempt this at home without a trained professional. Okay, so what we've got here is we've got a series of large-scale capacitors that I've used now for the Wimshurst electrostatic generator so that we can do small-scale and larger-scale capacitance experiments. Now what we got is just a simple design. They're PVC pipe design. I've got 2 different ones here. The large ones in the background are out of 3-inch PVC pipe with a cork top and an interior lining that I've just put around a piece of paper that was the right size for the inside, put the aluminum foil around the paper and slid it down on the inside of that 3-inch piece of pipe right there. That's a harder way to do it. These smaller designs here is what I'm going to show you right now. Just how to build a small, high-powered capacitor system. First of all, I don't have this all connected, so I could show this to you. And I want to show you what's here on the inside. This is just the inner tube, and what I have is a 2-inch piece of PVC pipe and an 1.5-inch piece of PVC pipe. And they're very thick gauge PVC, so they sit really tight with each other. If I show you that, there's almost no air space around it, just barely enough for the wire here to go between the 2 of them. And I'm going to pull the cork out of the center tube here and just show you the cork has a reset nut up inside of the piece. And what I've done to create this cork is used a piece of 2x6 and a hole saw at the right size for the inside of the diameter of the inner piece of PVC pipe. I've got a bolt, some washers, everything hooked onto that. If I put that back in there, I'm going to show you exactly what it's there to do. You'll actually take these loop of wire that you see here, you'll actually wrap it around the head of that bolt between the 2 washers there. You're going to twist it around a couple times, tighten that all down with your discharge tips here. These will actually be able to be moved off of these larger capacitors and attached to the top here. I may make my own set for this capacitor bank so I don't have to keep undoing things. And that'll actually bolt right off the top here. Let me show you what's going on the inside of this. Take them off really carefully because you don't want to hurt the interior aluminum foil. And here's what I've got. I've got basically 2 pieces of PVC pipe equally wrapped in height. So you notice they're equal and parallel in height there on both the top and the bottom. That's a full roll height-wise in aluminum foil on each one of these. These will wipe you out. I'm not joking, so be careful. I've got all this wire here is actually totally stripped all the way around, so it's bare copper wire. it comes down and makes a good contact, wrapping all the way around the interior piece of aluminum foil on our capacitor. So there you go, there's our interior rod. It's just aluminum foil. I actually used super glue and glued those onto there, so they're not going to move a lot. I've got all my edges, the top edges and the seam edges and the bottom edge all glued, so that way I'm not ripping against them when I slide them in and out. Typically you're not going to move these very often, but there is some neat experiments that you can do where I can actually put the exterior tube on here, charge it up with the Wimshurst electrostatic generator, and remove this exterior tube, move the two way away from each other, leave that there for quite a long time, as long as nothing comes in contact to discharge either one of them. I can bring them back together and they're still going to work, still hold a capacitance charge to them. So once again, you just take a 2-inch piece and you're going to wrap aluminum foil all the way around the 2-inch piece of pipe, and you got to make sure you keep the foil without any crinkles in it. Do a lot of work to try to get it as smooth as you can, and it's almost impossible to get it dead smooth, but try to get it as smooth as you can. Same with the interior piece. And what I've done in the bottom to hold the interior piece is I first made the hole saw cut for the size of the inside of this 1.5 inch PVC, and then I made a size cut for the outside diameter of the 2-inch. So it's actually got a little peg sticking up in there left over. I didn't break off the interior peg from the hole saw that this actually sits down on, just like the peg you see as the lid here. This actual peg here resembles the same thing that's sitting up still attached to the lower 2x4. I've just knocked over the outside one. Just be careful with these, you don't want to rip them. So anyways, that's all that's holding that on there. That keeps the interior tube nice and strong and sturdily mounted, while we can take the exterior tube and move it around, do what we want. Once again here, I'm going to try to set this carefully right back down over the interior tube here, and there you go. Now you've got a nice capacitor. It's easy to build. You can actually remove the exterior and interior, and you can actually put those into different experiment setups where you can run one from a long ways from another, even as a little backup home-built electric fence setup with a single charge in it. So there you go. These ones here are a little more difficult. They actually require a lot of time trying to get the interior piece of aluminum foil stuck inside of the same pipe. I don't have an interior pipe in these like I do on this design. These are actually a cork. Let me see if I can pull that out for you. These are a cork made out of wood with a bolt sticking down all the way through into the interior. And if I show you down in there, if the camera can pick up any of it, you'll notice the aluminum sitting on the inside, and you'll notice a little rough looking. That's a very difficult way to try to put it in there. That's why I tried to come up with this double tube design. And these actually have brushes off the bottom of the bolt right here that'll actually sit down and connect with the inside plate of that aluminum foil inside our larger capacitor bank here. Once again, we'll set our discharge balls to the same distance. So there you go. That's how to make a simple capacitor. These are very large capacitors. If you wanted to experiment at home, I'd take a piece of the same size pipe and I'd make it maybe 4 inches long. Just a section on either side, on the inside and outside pipe, about 4 inches of aluminum foil. That's still going to make you weak in your knees. It's still going to hurt a lot when you get hit by it. It's a lot less dangerous. Anything this big could actually kill you. So don't try a full sheet of aluminum. At the very most, try about a 1/4 sheet wrapped around the inside and the outside once again, and that'll keep it in a safe range. That's more like a stun than an actual death taser there. So there you go. I hope you enjoyed. Until next time, this was Mr. Teslonian and the Teslonian Man Show. Alright folks, we're on our final day here. We got some glue that's going to dry overnight, and tomorrow I'll do a video of putting this Wimshurst electrostatic generator into action. We've got it complete now. I've just got simple little things to do. I've got a connector bar that I've got to put in between the two capacitors right here. That'll be our way to switch the capacitor on and off. It actually connect the outside of both of those large capacitors to each other, and that'll complete the circuit, allowing us to use this system. Without that, you won't even see it working. What I've done for building capacitors here is I've got a 3-inch in diameter piece of black PVC pipe, and this is an entire sheet's width of aluminum foil wrapped all the way around the inside and the outside of this PVC pipe, and that's on both sides. Absolutely do not build capacitors this big if you're going to attempt this at home. Just a single one of these capacitors at this size, you may not think it, but just that little bit of aluminum foil fully charged right there will lay you out. if it won't obviously maybe even kill you. The two of them though combined, that's a dangerous combination. That's a large capacitor bank right here. So please build something maybe just, if you're going to use 3-inch, just go about 4 inches on either one of these in the height of your aluminum. That's a safe, nice, small capacitor. That's still going to hurt you. It's going to make you weaken your knees when you get hit by it. So don't take that as any kind of joke. But a capacitor this big, you've got to know what you're doing and never leave this thing charged. If somebody was to walk up and hit these two combined and fully charged, it would absolutely just probably end their lives. So anyways, just as a safety measure there, these are not what I'd suggest building as your capacitor towers. I just want a very high voltage discharge out of my the ends of my points here. And you can tell we've got our discharge balls mounted off the top of our capacitors. And I've got out of the center of this bolt, what I'm going to show you here in a moment, I've got a set of wire brushes that actually go down and touch the inside piece of aluminum foil. So it's just connecting a circuit from this bolt to the actual inside piece of aluminum foil, which is wrapped around at exactly the same height. You don't want to off-stage those, you want them right at the same height, inside and outside. That's coming off of here, both to our discharge ball on this side, and then going back to our comb. This bolt is insulated because of the wood being an insulator. It's just a 2x4 and a 2x2 and a hole drill through it. I've got a nut on the bottom of the bolt here so that you can actually tighten it all down. I've got the cable lug running up to our negative capacitor. I've got the washer with our comb sitting on it. Now you can see the comb positioning. It's done really well. They're positioned just off the surface of our disc on either side there, if I can kind of give you that aspect ratio. That's going to pick up all the static electric charge created by our brushes. And there's our brush tips sitting there rubbing against one of the aluminum plates here. And if you follow the line setup, if you follow the set of lines all the way through and across, the other brush is touching dead in line. So it's actually in circuit with this aluminum plate over here, and that's actually scrubbing off positive electrons and negative electrons. Well, let's go negative electrons and positive electrons, and making sure they don't go by each other. So there's more negative on one side and more positive on the other. And what these are doing is actually scraping electrons off of the aluminum plates. And what's happening here is, just like any capacitor effect, is those electrons are being held to those aluminum plates by the electrons on the opposite plate. And because these plates are rotating in opposite directions, and your combs are brushing in opposite spots, you'll notice the high spot on both of those combs is an opposite of each other. And that's allowing so that there's a positive charge on this side and a negative charge on this side. And those positive and negative charges, just like a north and a south pole on a magnet, will actually pull towards each other. So they're actually magnetically locking each other, trying to get to each other, and the dielectric material keeps that from happening until they get all the way around to our combs. So they're actually holding electrically, like through the electromagnetic effect, all the way until they get to our combs. Our combs are actually going to brush those electrons off, and we're going to in the middle of our capacitor towers. That goes on both sides. We do not put any of the charge actually directly to the outside. These are just going to be, like I said earlier, electrically connected with a connector rod between the two of them. And then once again here, we've got the positive charged electrons coming from this brush, sweeping across, being held electromagnetically onto the plates until it gets to this comb. That comb is going to take those positive electrons and bring it over into the top of this capacitor onto the inside of it. So now we've got both a negative and a positive charge in both of our capacitors. As long as the outsides are linked together, once we get up to charge, we're going to see an arc across these spark gap balls that we have here. That's actually going to be able to gap probably pretty big, so we've got them able to swing out and change the gap. They come almost all the way together or swing all the way out. Once again here, let me just show you the brush positioning is just above your combs. You don't want them too close to your combs, otherwise they're actually going to start picking off from each other, and it's going to mess up the event that's taking place right here. You actually can go a little higher up than I've done. I actually start moving these just a little bit. Once I get this up and running tomorrow when the glue's dry, I'll actually be able to adjust it just slightly and see where I like it to be, and I'll show you where exactly it seems to work the best once I get there. So we've got our drive rod once again coming off of there, which I'm actually going to replace tonight. I don't like how small it is, and I'm going to try to build a better way to grip it through here to get the belts tight enough to pull evenly. You have to put a lot of tension on there, and with these nylon pulleys I found it was a little difficult to try to get it to stay. So I'm either going to have to put in a different drive rod that's thick enough to drill all the way through to set that screw all the way through it, and that'll lock it together. So I'll show you that tomorrow when we go to use the system. So there you go. There's just the simplest way to build a Wimshurst electrostatic generator. It's just all made out of wood, this whole platform. If I go and just grab this one side here, you notice it's all screwed together. It's all one platform, so you can move it around, nothing's getting jostled, because the last thing you need to have to do here is try to deal with these two large capacitors in any other way. And also, the last thing here that I've got to do is also put a handle that's linked to this discharge rod on either side. There'll actually be wood insulated handles that'll be all the way out over here, so you can actually maneuver your discharge points from long ways away from either side. So until next time, I hope you enjoyed. This is Mr. Teslonian in the Teslonian Man Show.